Hey everybody, Lars here. Another day, another video. I decided instead of waiting until Sunday morning, I was going to get online tonight and do your final review video for Unit 5. And that's going to be the little knicky-knack parts that have to do with cleaning up object orientation. The big part is understanding how classes work and how you get an object and constructors and methods. And then you need to understand inheritance and polymorphism, because these are some of the reasons we do object orientation, to allow ourselves to reuse our code and to do things in a clever, efficient way. But there's a bunch of extra things that you need to know about too, which are pretty cool features at the end of the day. So what I'm going to do is I'm going to bring up the same code I used for the second review video. We'll review it real quick. I don't want to, make it crazy and do the second video all over again. And then we're going to add these 3 different features I want you to see. And then after that, I'm going to show you that classes, just like functions and constant variables, can be put in a library, and we can import them and use them just like we would our functions. But we have a lot of stuff to do, so let's get started. As I told you yesterday, we've finally gotten to the point where I don't know if I'm going to fit all the code on the screen anymore. You see, we have our animal class, and underneath it we have our cat class, where we created cats, and here's where we created Fred and all our animals and did all our work yesterday. All right, we're going to get rid of this because we don't need it anymore. And what I want to do really quickly is show you how easy it is when you have a base class like we do with animal to create a whole bunch of different classes. And basically what I'm going to do here is I'm just going to copy and then paste cat and create a dog class. And it's as easy as just renaming it dog. I don't refer to the class name anywhere here. So all we're doing is inheriting animal and giving our dog a color only when we ask it to speak. I'm going to make it say woof instead of meow. Boom, done. Now we have a dog class. It's that simple. And just as a quick review, I'm going to say D1 equals dog. We will name him Fido. We will make him 35 pounds. And we will make his color brown. Okay. So I run that. I should get nothing because I just create the thing. This is from what I ran before, so don't let that freak you out. Let me see. Okay. Let me make sure Fido is doing something. I will print d1.get, and I'll print his weight. So we get the 35. We can see that Fido is working. So what happens here? We want to print d1 get weight. D1 is what? It's a variable holding a dog object. So I go to the dog class, and I go down here, and I say, is there a get weight? And there is not. So I say, do I inherit from something? And yes, I do. I inherit from animal. So I go up to animal, and I look down the methods, and I see, is there a get weight? Yes, there is. So it returns self.weight. I believe Fido was called with 35, so it returns 35, and that's what gets printed over here. Okay, so you'll see a lot when you have base classes. That's what we call these bigger classes that we inherit from, that it's really easy just to copy these specific classes and then really quick fix them up so you have a specific animal. So now we have a cat, we have a dog, and we have a regular generic animal. Okay. Now, for the sake of argument, let's say as I go through my program, I want to count how many animals I have as I create them. So let's say I want to have a variable that I can keep track of that is based on the class that the object was created from, not necessarily the object itself. Because when the object is created, it has its instance variables, but those are just for those objects. Those aren't really something that's overall for everything that was created with that class. But we can create a variable like that, and they're called class variables. And the way you create them is you create them outside of the constructor. And when I do them, I usually do them right after the definition. And really all you have to do, we're going to call this animal count. So I'm just going to call it a count, is you just have to declare the variable, okay, and give it a value. and say when I first use this class, boom, boom, I'm actually creating an object for the class that all of the other calls are going to go to when they instantiate and create their objects. There's an overall class object that's going to maintain all of these class variables for us. Now, when we have these class variables, they will be accessible by the objects created with this class. Now, let's say in this example I have an A count. Well, what do I want A count to do? I want it to increase by 1 every time I create an animal. So what happens when I create an animal? Well, I run the constructor. So what do I want to do? I want to come here and I'm going to say A count plus equals 1. And that would increase the A count by 1. But I can tell you right now that if I were to run this program, it would blow up. At least I think it would blow up. Well, we're going to find out. Let's go. Yay, and it blows up. Like I always say, happy to see that error. And the reason it blows up is because this class doesn't know what A count is. Because I passed in self, name, weight, all these single variables, it sees A count. It says, what is that? You have to tell it that it's a class variable. And the way you do that is put the class name in front of it. Yes, thank you, Bible. Okay? Now it says, oh, okay, animal. And I know it's animal because I defined the class. It's not like it's an object that hasn't been defined yet. It's the actual class I want to use because it's a class variable. Now if I say animal.aCount1 and I run it, now everything's okay again. And that's incremented by 1. Now, like I do with these other things, and I guess I'll put it here, what you want to do is, I'll call it get A count. Self return as usual, animal dot A count. And there we go. Now we have a getter for it. So I could go down here and I could say print d1 dot get A count. Boom, and it prints 1. Okay. So now I have a class variable for all of the objects that are created with this class. And whenever I create one, I'll increase it by 1. So just doing 1 isn't good enough. Let's say C1 equals cat. And we'll bring back old Felix. And Felix, I forget what Felix weighed. And I think Felix was orange. So now Felix is back in the game. And let's grab these. Control, paste. Change these to C's. And we'll be in business. So now if we rerun, you can see we have Felix's weight 12. And now there are 2 objects. Okay. Now what's interesting about this, I'm getting a dog object here. I'm getting a cat object here. Okay. So let's just do Felix. C1 is equal to cat. Okay. With Felix 12 and orange. So when I create cat, what do? I go up to cat. And I say init self name Felix weight 12 color orange. I call the animal constructor. When I call the animal constructor, that's when it gets clicked. Okay. So anything that inherits from animal is going to click that animal counter. It's not just things that are going to use animal and get an animal object. It's anything that inherited as well, because I'm increasing that class variable in the constructor. So as you noticed, I'm using dog and cat, which are 2 classes. They're smaller classes that inherited from animal, but they still count as animals as far as that class variable is concerned. Okay? Now, the other side of the coin, and it's going to bring us to our next topic. What if I wanted to delete one of these animals and I want to decrease that class variable by 1? Well, what would I do? Actually, let's create one more little beastie here. We'll say E1 is also a dog. We will call him Rex. And Rex will weigh 23 pounds. and Rex will be an Irish setter. We'll make Rex red. Okay, and then we will, might as well do the, yeesh, didn't want to do that. Put it back, put it there, and make these E's. All right. So now we have 3 animals here. So what if I want to get rid of one of these animals? What would I do? Well, when I create an animal, I have a constructor that creates the object. Now, if I want to get rid of an object, I need something that's kind of the opposite of a constructor. And in object orientation, we do have a method like that. It's called, big surprise, the deconstructor. It's kind of the opposite of the constructor. Back a long time ago, 70s, 80s, memory was scarce. So taking care of your memory was a big deal in computer programming. You used to allocate memory and then take it back, put it back into the heap where you got your memory and blah, blah, blah. Now we really have a lot of memory, and memory is cheap. We're lousy with memory. So taking care of memory isn't such a big deal anymore. You'll find that you can get a class, even at the college level, on object orientation. They don't even mention deconstructors anymore because you don't have to get your objects back. Just leave them out there, you know. But for the sake of the niceties as far as Python is concerned, I do like to mention deconstructors because it's good to be smart with your memory, and you want to be efficient, and you never know when you're going to be in a situation where you want to do something, you know, properly and take care of your memory right. So I usually tell people about deconstructors, and the way we do them in Python is, now the constructor is usually the first method, and I usually make the deconstructor the last method. So I'll go down here and I'll say def, and it's a dunder, and it's del for delete, and then self. And that's how you define the deconstructor. Now what am I going to do? In this case, I'm just going to print the animal. Now let me say this. An animal has been destroyed, which is terrible. End paren, comma, and then I'll just name the animal, self.name. Boom. And then I'll say a count minus equals 1. So I decrement. And actually, like I told you before when we created it, I better call it animal.acount so it gets it right. Okay? So now we have a deconstructor in the animal class. It's always a good idea if you're going to do deconstructors and different things like that to do it in the base class. That way, you know, you can use it for everything that you inherit from, like cat and dog. Let's go test it. We come down here. I have D1, I have C1, I have E1. What do we want to do if we want to destroy something? First, let's run it and see what we get. All right, we got everybody. We're up to 3, so we know we're in good shape there. Let's say I want to delete something, an object. What's the command? Dun-da-da, del. If you go back and look, you'll see it's one of your keywords, and you'll see lovely idle making it orange for us. So we know that it's a keyword. And then you just have to put the variable name. So let's make this a dog party and get rid of Felix, C1. Okay, we're going to delete C1, and then I'm going to print. Now I'm going to use one of the objects that are existing because I just got rid of Felix, so I can't use him. So I use E1 dot get a count, and if I'm not mistaken, that will tell us that there are now only 2 animals left. First, just so we have something to separate ourselves, let's do this, and then we'll know. Oh, dun 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 dun. Nothing like a typo. All right, now we're in good shape. So you see we ran the regular program, then I have my things. An animal has been destroyed, Felix. And then it went from 3 to 2. So what happened? We deleted C1. What happened when we deleted C1? C1 was created with the cat class. I go to the cat class, okay, and I look for the dunder del method. Is it there? No. So I inherit from animal. Is it in animal? Yes. So I print an animal has been destroyed, just like you can see it here with the name Felix, and I take the animal.a count and I decrease it by 1. But I don't print it yet. That was the last thing I did right here. Then I print it. So I say, what's E1? E1 is my dog. I know you're thinking, well, that doesn't have anything to do with what we just did. But it doesn't matter. I'm just using this variable because it allows me, I know it was created with that class, so it'll let me get to the class variable. So it says get a count. So I go to the dog. Is get a count there? No, but I inherited from animal, so I go up to animal. Is get a count there? Yes, it is. So I return animal.a count. It was decremented here, so now it is 2. Okay? So if I'm going quick, slow the video down, stop it. As always, this code is going to be put on, I'll rename it, and I'll put it, because I think I already put animals up there under when I did it last night. So I'll rename this, and I'll probably call it main animal when I'm done, and then we'll have an animal library with all this code in it, so you'll be able to see it, okay? So that's how deconstructors work. It's dunder, del, dunder, and then you put what you want to do when you destroy an object. And to destroy an object, use the del command, del, and bloop, it gets rid of it, okay? Now there's one more thing we're going to do, and it's neat, and I want you to see it. We're going to print boom, 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 just to separate things out again. And then I'm going to do this. Print D1. Okay? I'm going to print my dog variable. All right? Just like you print 7, you print a string, you print a floating point value. When you print it, you show it. What happens when we just say print my object? Let's go take a look. All right, look at that. Now, I think we run through this in the slides. That is a memory location. And I'll actually tell you, it's a dog object, and it's at that memory location, okay? It seems a little weird because we said print, and it gives us that. Well, this is the little secret. Everything we've been doing so far is really based on a big class called the superclass. When you ask for an integer, it goes to a class called integer. And in that class, when you say print the integer, it has a little method that it runs that sends back what you should print. In that case, the integer itself. Or float. There's a big class called float. And if you have an object that's a floating point and you run print on it, this method sends back what you should print, the actual number itself. That method is what we're going to write for ourselves now. And it's called, and I usually do this right before my deconstructor because the deconstructor is always last. But we call that dunder, str, or string. Okay? Let me just give it a self. And then what string does is return, a string. And that string is what the print command will throw to the screen. Okay? This is an example of overriding all of the function or the methods that come with the superclass, that big overarching class that every class inherits from. Everyone has a dunder init. Okay? We override it when we write our own. Everyone has a dunder del dunder. We override it when we write our own. Well, everything also has a dunder string dunder. You can see here what it does is it just spits out the memory location because that's all it can really do. You don't know what an object is beforehand. I mean, this is the superclass. This is the most generic thing you can have. So it doesn't know anything about the objects you're going to create. But there's one thing it does know. It can spit out where it is in memory. I mean, that's going to be true no matter what object you ever create. It's always going to be sitting in memory somewhere. So that's what Python does. It basically tells you, hey, I don't know what the hell I am, but here's where I am. And it throws back the memory location. Well, what we're going to do now is we're going to say, make the A string equal to the object name is, we'll do a plus to concatenate, and then we'll just say self.name. So we'll throw out the thing's name. A lot of times, the string methods for objects will just dump the instance variables. In our case, we're just going to do name. But then there's one last thing you have to do. Always make sure to return it. return a string. That'll throw an error if I do that. Okay? So now I've gone to animal and I've overridden the string method. So now if I print an object like I did down here, print D1, it'll use it. So when it uses it, it'll create this string. The object name is, and then the name. So in our case, D1 was Fido. So it should say the object name is Fido. All right, let's find out. Hold your breath. Yay, the object name is Fido. Oh, my OCD will not allow that to continue. Space, save, rerun. Oh, thank goodness. The object name is Fido. So that's what happens. You print D1. What is D1? D1 is an object that was created with dog. So we go to dog. Is there a dunder string dunder? No, but we inherited from animal. So let's go up to animal. Dunder string dunder? Yes. Create a string called the object name is self.name and return it. That's what print uses. Okay? If I had time and I don't, I could even show you that we could override that for integers, floating points, strings, for anything. If we override that dunder string dunder, we can tell any object how to behave when print is run on it. Okay? So that's how we do that when we have objects. That's a fairly neat thing to know and do. And it's actually helpful with debugging. If you can just use the print statement to do an instance variable dump anytime you want to, comes in handy. So I used to set them up so it would do variable colon, variable colon, variable colon, all in one little line. It was almost like serializing it. And then if I needed to debug in the middle of my program, I would just do a print, boom, and it would come out. So I always used to override the string. You know, whether I was going to use it or not, I always made sure that that was there. Okay? So that's basically the main three things I wanted to get across to you as far as object orientation was concerned for this particular section of the slides. The class variables, the creating of a deconstructor and seeing how that works when we delete an object instead of creating an object, and the overriding of different functions. You've seen us override the speak method when I had the dog say woof and the cat say meow, and that kind of allowed us to implement polymorphism. Now you can see we're overriding the DEL to create our own custom deconstructor. We're overriding the dunder string dunder in order to create a string that'll be used by the print function. So you're seeing how we can override our methods as the systems work and we start doing object-oriented programming. Now I'm going to do one last thing here because I want you to see it in action. You see I got a dog class. You see I've got an animal class. It's a pretty big deal here. Actually, you know what? Let's do this. I usually delete my... I'm going to delete this, but watch. I'm going to save it first. Copy. Then X. Because I noticed I already have here a library for animals. So what am I going to do? I'm going to save as, and I'm going to call it animallib.py. Do I need to have the suffix? Call it animallib. All right, animallib.py. Nice. That contains all of my classes. New file. Uh-oh. This is going to get crazy. Yeah, I don't need main anymore. All right, what do I have to do? There's one thing I have to do here. I have to say from animallib import animal cat dog. Correct, it's animal, right? Yep. So now I have a library for animals here. It's called animallib.py. It's got my class here, cat, dog, right here. I grabbed all our other code from before, and I just stuck it here. Main prog for animal classes. And I imported from the animal lib the classes, just like I imported functions, just like I imported the constant variables. All right, I got to give this bad boy a name. We will save as, and I will call it Animane. .py? No, I don't need it. Animane. All right. Holding your breath. Gonna run it. See if it works. The tension is too much. And it does. Okay? Does all the behaviors and runs exactly like the run before when it was all in one file, but now we've compartmentalized. We're importing our classes just like we imported our functions when we did Harshed and ISCET, and just like we imported Hodges. I mean, this is what we do. We import classes. So you could have libraries. You'd be surprised if nowadays in more modern computer programming, our libraries are usually filled with classes that you run methods on when you create objects instead of functions. Back in the dinosaur days when I was a kid, they were usually full of functions. We called them dynamic linking libraries, and they'd be all full of functions. Nowadays, I'm sure you've heard the term, we have class libraries, where you have access to all these classes, and then you can instantiate an object using these classes and then run all the methods on it. Okay, and that's the way you get the behavior that you used to get just by running your functions. So you can, especially as it pertains to the final project, when I say in the rubric, I want to see a library of your creation with functions and classes and all these things, this is what I'm talking about. You create your class, and you can see this is a long one. It's got the animal, it's got the cat, and it's got the dog, and you just put it in your library, and you never have to write it again. Or if you think of some new functionality that you want, you just come in here and add it. You know, you already have it. If you want to create another animal, you could do it just like you did cat, dog, piece of cake. Okay? And then when you come here, all you have to do is import it, and then you can use it to get your work done. All right? So Animane and animallib.py will both be in your Unit 5 folder. Later on tonight when I post this video, hopefully I'll do a real quick announcement. I don't want to scare you by throwing up all these announcements at 3 or 4 in the morning, but I'm busy. I've been busy the last couple of nights, so I'm up late trying to get this stuff done. Although the other night I watched Star Wars, so that's not completely true. All right, so we are now at the point where I believe you have all of the resources you're going to need for Unit 5. You have your slides. You have the Zell chapters. You have your homework assignments. You have all 3 review videos for this long 3-week unit. And you now have, 10 days to get the assignments done and to do the forum post and to prepare for the quiz. So you should be in good shape. I want you to check out all these materials. Go to the resource folder and get these programs and play with them. I think I had no, actually, some people sent me some email. I'll probably get to you tomorrow, and I'll get your questions answered, and don't worry about it. Don't forget, this coming Thursday, if I'm not mistaken, the 14th, your design document is going to be due. I had a couple people come by and ask me some questions about the design document. Again, like the proposal, don't let it freak you out. It doesn't have to be super long, 2 or 3 pages. But what this document has to be is telling me exactly what you have and how you're going to do what you intend to do. Okay? It's not like the proposal. The proposal was a pitch. The proposal was an elevator speech. That was like what you'd see on Shark Tank when somebody introduces an idea. That was high-level stuff. The design document is where you tell me what kind of data you have, how you're going to clean it, what you're going to do to it, and then how you're going to get from A to B to try and discover something about your data or do something useful. Simply put, just describe your situation in words. The magic of double spacing will blow your design document up nice and fat, and you send it along, okay? It doesn't have to include the graphics and the other things that the proposal did, all right? So don't let the design document scare you. Do a good job on it and describe what you're doing and how you're doing it, but don't let it freak you out, okay? So make sure you're getting together with your groups and you're putting that together and getting things done, okay? I believe the boys got going with the assignments today, so hopefully tomorrow night I'll be doing grades for Unit 4. I will get them to you soon, so you know where you stand and you know where you're sitting. Regardless of where you stand or where you're sitting, though, concentrate on Unit 5, okay? The Unit 4 grades will take care of themselves because if I don't get to it tomorrow, then I'll get to it on Monday. But don't worry about that for now. I'll be getting them to you as soon as possible, okay? All right, good. Then you have a good night. You got your Unit 5 resources, and like I say in the homework assignment, don't wait a day and then send me emails saying, I don't know how to do this. You puzzle it out for a while. That's the secret. You got to Google, talk to your friends, try different things, and you'll see all of a sudden, oh, yeah, I could do that. Oh, yeah, that would work. Boom, boom, boom. And all of a sudden, you're going to figure out a way to do it. All right? And that's the cool thing about computer programming. When you find out how to do things for yourself, then you implement it and you get it done. You're like, wow, that's pretty cool. I got that all done. I don't want to take that away from you by telling you how to do it. I want you to do it for yourself, okay? All right. Then I am going to get out of here. You have a good night, and I will talk to you very soon. Be good now. Bye.